Good day, everyone. We are the Customs Inspection and Logistics team.
Today, we are going to demonstrate how fundamental mathematical concepts, specifically surface area,
Volume and rectangular solids
that are vital to modern customs administration.
To begin, let us define our core concept simply. First, rectangular solid. A three-dimensional solid object bounded by six rectangular faces. Second, surface area. The total area of the outer surface of this three-dimensional object, which is crucial for determining material needs and protection. Third, volume. The total amount of three-dimensional space enclosed by the rectangular solid, which dictates capacity and loading limits. In customs administration, understanding these measurements is essential for assessing duties, optimizing warehouse space, and ensuring safety during transit.
Now, let me discuss the three core application of this measurement in real-world custom operation. First, cargo container measurement. Accurately measuring the external and internal dimension of standard shipping containers ensure that we adhere to weight and space limits. Second, freight and shipping computation. International shipping lines and custom agencies calculate freight charges and duties based on volume weight, dimensional weight, and space occupied. Third, port logistics and anti-smuggling. By knowing the precise volume of a containers, inspectors can verify the manifest against the actual physical cargo. Significant discrepancies alert us to potential smuggling or misdeclaration.
Let us look at a practical demonstration. I will compute the dimensions, surface area, and the volume of a standard 20-foot equivalent unit cargo container of this miniature. Let's assume that this miniature container has the following external dimensions. Length is 6 meter, width is 2.4 meters, and height is 2.6 meters. To find the volume of the formula, I use this. Volume is equals to length times width times height. Let's multiply these dimensions. Volume is equals to length times width times height is equal to 6 times 2.4 times 2.6 is equal to 37.44 square meters. This means that container can hold the maximum internal volume of 37.44 square meters of cargo. To determine the total surface area of our cargo container, we use the standard surface area formula for a rectangular solid, which is surface area is equals to 2 times length times width plus length times height plus width times height. First, we find the area of the three unique pairs of opposing faces. The top and bottom faces measure 6 by 2.4 meters, giving us 14.44 square meters. The front and back faces measure 6 times 2.6 meters, which equals to 15.6 square meters. Finally, the left and right side measure by 2.4 by 2.6 meters in total of 6.24 square meters. Adding these three areas together give us a base sum of 36.24 square meters. Since each face has an identical opposite pair, we multiply this sum by 2, resulting in total surface area of 72.48 square meters. This measurement is vital for determining space requirements and freight charges in actual operations.
These measurements affect our core customs operations. Customs duties. Duties are often assessed based on the dimensions, volume, or weight of the goods.
Accurate volume measurements ensure correct valuation and taxation. Freight charges. Shipping lines compute freight charges using either the actual weight or the volumetric weight, or CBM. Accurate sizing ensures that charges are calculated fairly. Storage allocation. Knowing the total surface area and volume allows port authorities to properly allocate warehouse space and safely stack cargo. Cargo safety. Calculating the volume of containers help personnel adhere to strict weight limits and load distributions, preventing accidents and equipment damage. Anti-smuggling operations. Discrepancies between the declared dimensions or volume on the shipping manifest and the actual physical volume alert are inspectors to hidden compartments or misdeclared items.
In summary, accuracy in measurement is critical to trade compliance. Incorrect computations can lead to underpayment of duties, severe safety violation at sea and delayed port operations. As future custom administrators, mastering the geometry of cargo solids ensures that our ports run efficiently and securely.
And that's the wraps of our quick tour of the math behind the cargo. Once again,
We are the Customs Inspection and Logistics Team. Thank you so much for watching and stay safe.